Here we are with another tutorial with Jesus Christ. Thanks for coming back, and welcome to another educational lesson on how to program in C++ in OpenGL. Okay, so in the previous tutorial, what we accomplished was 100,000 cubes. If you did everything correctly, this is what you should have. You should have about 100,000 cubes bouncing around, flying around in your little window. And this is the syntax for it all. You can pause the video anytime to make sure that you have everything typed up correctly. And we're going to go on a frag shader. That's your frag shader. And this is your first shader. Okay, and again, if you have typed up everything successfully, you should have your 100,000 cubes, or however many cubes you would like to render, depending on what you've typed in your syntax and in your code. So in this lesson, what we're going to be doing, we're going to be starting on page 83. And on page 83, what we will accomplish is a cube and a pyramid. And this is the syntax you're going to need in order to get your pyramid position floated up. You should have this PDF document from the first video. If you don't, please go back to the first video where you created your red window setup, and you can download it. And you can highlight all the syntax and the text inside of the PDF document or the PDF book. And this is what we're going to be accomplishing in this video right here. We're going to have a cube, that same colorful cube, with a little pyramid, a little 3D pyramid floating above it. Alright, so let's go ahead and get started. Let's get our hands dirty so we can accomplish this. And so what we're going to do, we're going to go down to our define num VBOs, vertice buffer objects. And we're going to add float pyramid location X, Y, and Z. And we're going to remove our utils, util equal to utils. And we're going to remove GLUint matrix location model location, view location, and projection location. We're going to remove this line. And we're going to add GLUint, model view location, and projection location. And we're going to remove display loop I, because we won't be needing that anymore. And we're going to remove our time factor. And we're going to remove our float TF. And we're going to remove our TMAT and our RMAT. Now we're going to go down into our void set of vertices. And we're going to need the float vertice locations for our pyramid. You get that in your PDF document. And you're going to paste that right beneath your float vertex positions for your cube. Okay, all this is for the cube, so you're going to need a set of float vertex positions for your pyramid also. Okay, next what we want to do is we want to include our GL bind buffer and our GL buffer data. Okay, because this thing right here, GL bind buffer VBO0, is for the cube. GL buffer data, GL array buffer size of vertex positions, is for the cube. It creates to locate the buffer's object data for the cube that we have. So we're going to need something similar to this, but specifically for our pyramid. So in situations like this is what you want to type. You want to type GL bind buffer, GL array buffer. And beneath that, you want to type GL buffer data, GL array buffer, size of, pyramid positions, GL static draw. Okay, so this whole section right here is representing the buffer data and the bind buffer for the cube. And this right here is representing the bind buffer and the buffer data for your pyramid. So we're going to scroll down to our void init. And we're going to change our camera Z to 8.0f. We're going to add cube location X, Y, and Z. X is going to be 0.0f, location Y is going to be negative 2.0, and your location of Z is going to be 0.0f. Beneath that, we're going to type pyramid location X, which will be at 2.0, and your location Y is going to be at 2.0, and location Z is going to be at 0.0 float. You know what? Go down to your void display now. It's going to be a lot of coding that you're going to have to do. We're just going to rip all this out. And we're going to type GL clear, GL depth buffer bit, GL use program, rendering program, model view location, GL get uniform location, rendering program, MV matrix. Projection location, GL get uniform location, rendering program, projection matrix. View matrix, GL mathematics, translate graphics library mathematics, mat 4, 1.0f, GL invec 3, camera X, camera Y, camera Z. Now we're going to draw the cube using buffer number 0. Okay, this is GL uniform matrix 4FV, projection location 1 GL false, GLN value PTR, projection matrix. GL bind buffer, GL array buffer, VBO 0, and beneath that we're going to type GL vertex attribute pointer 0, 3, GL float, GL false, 0, 0. Don't forget your semicolons. GL enable vertex attrib array. GL enable vertex attrib array. GL enable depth GL depth test. GL depth func GLL equal. GL draw arrays, GL triangles, 0 and 36 vertex points. Alright, so now we're going to get down to drawing the pyramid using buffer number 1, because all this right here is using buffer number 0, which draws the cube. GL uniform matrix 4FV, model view location 1 GL false, graphics library math, value PTR, model view matrix. And this line looks similar, but this is a representation for the projection location. GL vertex attrib pointer 0, 3, GL float, GL false 0 and 0. GL depth func GLL equal. In this line right here, we're drawing GL draw arrays for different amount of vertex locations. Okay, so that's it for our pyramid, and that's it for our cube that we're drawing. Okay, so now what we want to do, we want to go into our fraction and check to see if we need to do any changes in there. And it's saying here in my notes that we don't need to do any changes, so we'll just leave our fractator the same. And we're just going to go ahead in our vert shader now. And we're going to delete all this out because we're not going to need it anymore. And beneath version 4.3.0, we're going to type layout location is equal to 0 in vec3 position semicolon. Uniform mat 4 in V matrix semicolon. Uniform mat 4 projection matrix ALVEC4 varying color, semicolon. And you want to type up a void main void. And beneath that you want to type GL position projection matrix multiplied by model view matrix multiplied by VEC4 position 1.0. And beneath that you want to type varying color equals VEC4 position 1.0 multiplied by 0.5 plus VEC4. And these are your position located. These are the locations. RGBA, I'm sorry, these are your colors. All 0.5s, semicolon. Alright, so now that we've typed all this up, let's keep your fingers crossed, and what we should have is a cube and a pyramid, which is similar to the image that you see right here in the PDF document. So I'll go ahead and hit F9. I'm sorry, we'll go ahead and run a build. And it shows down here that we're not getting any errors or warnings. And we'll go ahead and click run. And that's exactly what we should get. So if you have any questions, if you're kind of stumbled about, you know, what you just typed up, just go ahead back in, was it page 80, 85, where it starts at page 83, and you just read through the section until you get up to page 86 and stuff, and it tells you everything that you typed, gives you more information about everything you typed up. Alright, so that's the tutorial. And if you typed everything up correctly, this is what you should be seeing right here. Again, that's it for the tutorial, and thanks for watching, and I'll see you in the next video. This is Jesus Christ.